Okay, so today we are going to talk about pivot in SQL. So before we talk about pivot, has everyone heard about pivot? Do you know the concept of a pivot, not just in SQL Server, but in general? Have you ever used pivot in Excel spreadsheet? Have you used pivots? Okay, that's completely all right. So a pivot, if you know the literal meaning, it's like a turning point, if you will. So pivot in SQL Server, if you haven't worked with Excel, it's very similar to or gives the same effect as pivot in Excel. Okay, so today we are only going to focus on pivot in SQL. What I will try to do is show you the concept, show you the syntax, how it's done, and maybe show you a couple of examples which will help make that concept a little bit more clear. All right. So with that, let's look at what is pivot. So pivot is the same, like I said, as in an Excel spreadsheet. What it basically does is it converts rows into columns. So if you have rows of data and you don't like the view that you see, you would rather have a different perspective of the same data, look at the same data slightly differently. That is when you can convert your rows into, or rather your rows into columns, and that is what a pivot does for you. Okay, it will be clear when we look at some examples. So this is the formal definition of a pivot. A pivot is a SQL Server operator. So when we say a SQL Server operator, it means that you can actually write a query using the keyword pivot, which will allow you to operate on a certain data set. That means manipulate a certain data set so that you can convert the rows in that data set into columns. All right. So pivot is a SQL Server operator that can be used to turn unique values from one column into multiple columns in the output, thereby effectively rotating a table. Okay, so what you are doing is, what pivot allows you to do is take unique values from one column. Okay, your column can have repetitions of values. You take unique values and you make columns out of those values, meaning you have one column and you are effectively turning it to make more columns, meaning spreading it out. Okay. So let's look at this example on the screen. Look at this table on the left-hand side, which has three columns: student, subject, and their marks that they got in their some quizzes or exams or tests. I see two students, Mary and John. So for Mary, I have three subjects: math, chemistry, and English, and how much they scored in each of their subjects. Same thing for John: math, chemistry, English, and their scores. Now, this view of this table, if you look at it, and if somebody asks me, like, who is better at math, who, between Mary and John, who is better in chemistry, it will be a tedious view. Like, I have to go row by row and see, okay, Mary in mathematics scored 98 versus John in mathematics scored 100. So obviously John is better at math according to this score. But it's a tedious task, like I said, to look at the table in this format, or rather to look at the data set in this format, and then derive a certain conclusion from this view. Now, if I had the same view in which I actually converted this column, I took the unique values. So look at our definition here. It turns unique values from one column. So that one column whose unique values I decided I'm going to turn is the subject. So I decided to turn the unique values math, which appears twice, chemistry appears twice, and English also appears twice, but I choose to make them unique and only take them once, and then turn them into columns so that math becomes its own column, chemistry becomes its own column, and so does English. And now let's look at this view. The comparison between the two students and their scores becomes so much more easier. Right? Isn't this much better a view? Like if somebody asks me who got better marks in math, and I can easily tell John got better marks. Who got better marks in English? I can look at just this column and tell, okay, they were very close, but Mary got better marks in English. So it's the same data. We did not manipulate the data, but just by rotating the table, we get a completely different vantage point of our data, and the data becomes more meaningful. Everybody with me? Yes, no, maybe? Yes. All right. So we see everybody understand the concept of a pivot. It does nothing but converts unique values from a column into multiple columns, spreads it out into multiple columns, thereby effectively rotating the table. So in this, we just took this column, made more columns out of it, converted unique values from this column into its own unique columns, and in doing so, we actually rotated our table, or we pivoted our table. So does everybody understand at this point what a pivot does? Yes? All right, cool. Let's look at this other easier example. So I have this other table, product, which lists products, rose, t-shirt, teddy bear, etc. And then the sum of sales of those products. So maybe it's units. I sold 53 items of rose. I sold 81 t-shirts, 7 teddy bears, and so on in my general stores. If I were to rotate this this particular table, this is what I would get. I took unique values from this column and made columns out of that. So rose, t-shirt, cup, they, instead of being rows, they became columns. And then against each one of them, I see how many of them were sold in my store. So this just gives me a better view. So why pivot? Why would you use pivot? The answer is right there, so that we can look at the data with a different vantage point, so that the data that we are looking at gives us a more meaningful picture, tells us a story, right? Helps us make better decisions, and helps us make decisions quickly, because now at a glance, I can look at and see that my best selling product is actually a t-shirt, and my worst selling product is a soft toy, teddy bears. So maybe I should, if I have a store, maybe I should invest more in different styles of, or designs, or colors, or sizes of t-shirts versus investing in more soft toys. So this is how companies look at, and folks like you and me analyze the data and present a picture that helps management make wise decisions about where to put their money and gain more profits. Everybody with me? Yes? All right, excellent. Okay. So because we are talking about why pivot, I just wanted to tell you, talk a little bit about perspective, right? Here we are talking about the way we look at data. So does anybody know what a stereogram is?
No, I don't know what that is.
Okay. Have you seen the movie Knives Out? Knives Out 2? Knives
Lights
Out.
Out 2?
No,
Yes,
no,
yes, yeah.
Knives Out.
Knives Out. No, I
Yeah,
haven't seen Knives Out 2.
the
No.
okay, Glass Onion. It just came out on Netflix.
Yes, I know what you're talking about. Yes.
Okay, so each of the characters, it's a group of friends, they all receive a box, right? And they are trying to open this box. And then somebody is able to open the box because there's a character, I don't remember the name, but I know Leslie Odom Jr. presses a button by looking at the box and then aligning his vision so that a button appears, which he presses, and then the box opens up.
Right. Okay.
So what a stereogram is basically it allows you to, it's like an optical illusion, right? It's an optical illusion of depth, which is created by flat two-dimensional image. If you Google it, but if you view the image in a particular way, then the three-dimensional image, it reveals itself in a different way. Okay, so that's exactly what, if you think about it, a pivot does the same thing. It gives you a different perspective so that something that's hidden in the data, it clearly becomes visible to you, like we saw in this example, right? It's the same data. We don't change the data, but the pivot gives us a perspective. It changes the way we are looking at the same data. So that's why it's so useful for data analysis. Make sense? Yes, no, maybe? All right. Another example, real life example that I want to talk about is, did anybody hear about this painting that was hanging upside down?
No.
For about 75 years. So it's a Mondrian painting that was hanging upside down. And recently, some German curator, she, did her research and said, hey, this painting has been hanging upside down for like past 75 years. So look it up. So it's like how you look at things, right? It changes. Perspective is everything. And pivot gives you perspective.
Right. Okay.
All right. So you understand what a pivot does. You understand the philosophy behind the pivot. Now we are ready to look at the syntax of a pivot. Are we ready?
Okay. Yes.
Okay. So this is the syntax from MSDN. All our queries are written select from, right? You select some columns from some source table or combination of tables, and then you apply some operators to it. So this may not make sense, but believe me, when we solve a couple of examples, then this will make more sense. But I want to walk you through this syntax nonetheless. So we select some columns. This is our first pivoted column, second pivoted column, and so on and so forth. So in this query, it would be something like select student math, chemistry, select student math, chemistry, English. That would give you a result set, something like this, because these are our pivoted columns. Okay. You select it from a data set. That data set could be a derived column, which in itself is a complex query that does some grouping, some filtering, what have you. So it does it from a derived table, which could be a query, which we are going to alias as something. So in your from clause, you can go crazy, write a complex query to derive that data set, which you are planning to pivot. And then we alias it. We say, name this as, my staging table, or A, B, C. You can name it anything. And then you use the keyword pivot, because this from clause is that data set that you are telling SQL Server, now I give you this data set, now pivot this. Okay. And once you use the keyword pivot, then follows the pivot syntax. You give the aggregation function, like you are trying to do, for example, in this, it's already done some sales. But are you trying to do a count? Are you trying to take an average? Are you trying to add up all the sales for that particular item, or for that particular year, or for that region, and so on and so forth? So you use your aggregation function, and then you say you want to pivot for, and then you supply a set of columns. In this case, those columns would be, and you have to name it in the query, rose, t-shirt, cup, teddy bear, book, because these are actually your column names. In this case, those column names would be math, chemistry, English, and so on. So then you, in your column names, you will actually give what you want to see as column names. What are those values that you actually pivoted? And then again, you alias that table as pivot table. I normally just call it P for pivot. And then you have an optional order by clause. Order by clause, do you have any background about order by clause? I can talk a little bit about it before we move forward. Does anyone have some information, knowledge about an order by?
I do not.
That's perfectly fine. What is order by? When I say order by height, that means you are somehow arranging your data in an order, right? So if I have 100 rows or 100 students, and I say order by date of birth, then they will just order themselves by date of birth. So that is exactly what order by does. It orders your data based on how you want to order it. You tell it order by this column, and it will order it by whichever column you choose. That's what order by does. So if you think about SQL, SQL is structured query language, SQL, and it is almost like Common English. You select some data from somewhere where some filter is applied, or from some table, and then you pivot it for an aggregate function where the values are in this set of. So if you think about it, as you do it, as you write a query, it's almost like plain English, except it is in a format that is understandable by SQL Server or the database engine. Okay? Yes, no, maybe?
Yes, okay, I understood that, yes.
All right, cool. So as you can see, this is when you write any query, that is going to be your format. Select something from somewhere, and then you will see most common a where clause, where this condition is satisfied. For example, select all the students from students that are currently enrolled where GPA is greater than 3.5. That's your SQL query right there. Okay?
Okay.
All right. All right, so again, talking about why pivot. So this is an example that you would actually see in real life, right? This is the data from a store. Looks like they sell different kinds of bikes. So I see children's bikes, comfort bikes, electric bikes, road bikes, mountain bikes, different kinds of bikes. And then look at this data, the model year for each bike, and how much was the total sales price for that particular model year is here, right? So this is the kind of spreadsheet that decision makers would look at and decide where to make improvements in the upcoming year, where to spend money on advertising, where to cut back because this is not a very popular product, and so on and so forth. Now, I have this data sitting like this, which, I can see, but it's not very meaningful. But as soon as I pivot this data so that I take unique values from my category column and make columns out of it. So I took unique values, children's bicycles, comfort bicycles, and just made columns out of them. And then I'm now organizing my data so that for each year, I see exactly how much was the sale for that particular kind of bike for that particular year. So this is a more meaningful picture for me. It's easy to compare. It's easy to read. Yes?
Yes, yeah, much easier to read.
All right. Okay, so that is what pivot is used for. You will mostly see if you are writing a report that you have to present to your manager, or writing, a data set that you want to present a certain aspect of the data to someone. That is where a pivot comes in really handy. All right. So before we try another query, I want to first try the first query. So if you haven't seen this before, this is the tool that we use to connect to SQL Server. It's called Microsoft's SQL Server Management Studio. And as you can see, I'm already connected to a SQL Server. I see different tabs over here. The tab that is most interesting is the databases tab, because I'm going to connect to one of the databases and try and run, or rather write, some meaningful queries. So I'm going to focus my attention on the sample sales database. Okay, can everybody see my screen, what I'm sharing? I don't want to be sharing the wrong screen. Can you see the SQL Server Management Studio and
Yes, I can.
the sample sales? Okay, thank you. I appreciate the feedback. Okay, so sample sales database has many tables, but I want to only look at one of the tables that I'm going to talk about. And let me see if I can show you that table. So again, I will write the query as select star. When I say select star, star means show me everything. Show me all the columns and all the rows in this table. Select star from somewhere, right? I have to give it the name of the table. And in this case, the table that I'm going to write my query or retrieve my data set from, the name is sale.sales. Let me change the context here to sample sales so that my IntelliSense kicks in. Sale.sales summary. And as soon as I changed my context, I see that Management Studio is smart enough to pick up. It has IntelliSense, so I don't have to type the entire table name. So when I say select star, look at that. I click the execute button and it retrieves all the data. I see this table has brand and category and model year and the total sale price for this brand, this category for this year. Now that's a lot of data to digest. I want to do something meaningful with this data. So first of all, I'm going to only select the relevant columns. I don't want to select all the columns. Okay, so how do I do that? I'm going to say select, and then I will give SQL Server the names of my columns that I want to see in my output or query result. So let's see if I can say select category. I'm going to copy and paste this part so that, again, my IntelliSense kicks in. There. So as you see, as soon as I told SQL Server that where am I selecting from, it becomes very helpful and starts prompting the names of the columns that it already detects in the table. So I want to see category. I want to see model year. And I want to see, I don't care about brand, but I do care about the total sales prices. So I want to see these three columns instead of everything. All right. So this is a good start. Now I see the relevant information that I was mostly interested in, but this is still a lot of data to process. I want to somehow group this data to make it more meaningful. And how do I do that? If only I could group all this data so that I could see all the category information. Like for this category, I just want to know how much is the total price. I don't care. Like for this category, I know that this for mountain bikes, this was for a certain brand. Another mountain bikes is, where do I see mountain bikes? This is probably for a different brand, but I don't care about brands and I don't care about, the other information. If someone can just tell me how much sales was made in mountain bikes. So how do I do that? Let's try this. So again, I'm going to first do the from, select from this table, and then I'm going to say select category, model year, and then I want to select the sum of the total sale prices. From this table, but as soon as I use an aggregate function, I need to do something else. And again, this is something we teach when we go into details of how to group the data. But in the interest of time, I will just say I'm going to group it by category and model year. Now, when I run this query, let's look at, so if you look at this, I have 41 rows. See, the last row is the 41st row. So if I run this, this is a much better consolidated picture because now it's showing me children's bikes in the year 2018. This doesn't have a column name. So let me give it some alias as total sale price. And now when I run this, all right. So isn't it better to process 21 rows as compared to 41 rows worth of numbers, right?
Yes,
So
I
now
would say so.
Okay. So it just makes, it gives you a better picture. It tells a better story. So now I know that children's bikes, I don't care what brand, but in 2018, this was the total sales amount. And same thing for children's bikes in 2019, it was this, and so on and so forth. Okay. Now, I just quickly want to show you what the order by clause does, just because we talked about order by. So now see how this this view of your data set changes if I say order by category. If I order it by category, and if I order it like this, now look at this. Isn't this beautiful? For children's bikes, now I see consecutively what was the sales in 2018, 2019, and 2020. So this view tells me a story that children's bikes have become less popular since between 2018 and 2020, because numbers don't lie. I can see that we made a lot of sales in children's bikes in the year 2018, but somehow it has dropped to only 32K plus in the year 2020. Yes. And if I change it by, instead of doing by category, if I change it by model year, this gives me a different picture. It's the same data, but just by changing the order by, it's telling me a different story because it's giving me a different vantage point of the same data. Everybody with me? So now
Yes.
let's come back to pivot. All right, let's come back to pivot. So what was our pivot syntax? Our pivot syntax was telling us something like, select your pivoted columns. For the sake of simplicity, I'm just going to say select star from. Now I want to do like a derived table, and for that I can use something like a subset, right? I don't want to see everything. I just want to see these. So I'm going to make this my derived table here. So I'm saying select star from this table, because this in itself is a table, right? This returns a table. It returns all the categories, model year, and sales prices. So this becomes my derived table, or the data set that I'm choosing to pivot. Everybody with me? Yes? This is the,
Yes.
all right. I'm going to call it as A. This becomes my derived table or data set that I choose to pivot or turn or rotate.
Okay.
All right. Now that I have decided this is going to be my data set that I pivot, I actually have to tell SQL Server pivot, right? I have to use that keyword pivot. So that's exactly what I did. Pivot, and then pivot what? I have to give it an aggregate function. So what's my aggregate function? I am trying to do a sum of total sale prices. So sum of total sale prices here. All right. And then sum of total sale prices for, I want to spread it out. What am I for? Category, right? Category is going to be, I want to see for different categories lined up. I want to see the sum prices in the columns instead of in the these categories, instead of in rows. I want to see them horizontally. So I'm going to say for category, okay, in, and then I give it the list that I want to see. And what's that list? I have a trick that I normally use. Instead of typing the list of all the bikes, like I could start typing and say mountain bikes, something like this. Like this is going to be my first column. Then my second column is going to be road bikes. These are all the columns that I'm telling SQL Server to spread out, right? Which I want to see as columns instead of rows. Instead of typing, let me copy paste this. So I could do this the tedious way, or I could just say select distinct category, DIS, distinct category from sale.summary. And this will just give me the distinct categories from, so I'm only looking for these columns. So let's do this. And then let's give it proper syntax, because they are going to be column names. I have to put them in square brackets. And of course, it has to be a comma separated list. Everybody with me?
Yes, I'm following you.
And believe me, this becomes easier with practice. This is just a like a snapshot, if you will, of what you can do with SQL Server. But what I'm doing here, it's it will come naturally when we start learning the course step by step by step. All right, so now I have given, I'm going to comment this out, and my little trick there is I select it and then I click this little button. It comments it out. If I don't want to click the button, I can also just manually type in 2 hyphens, and that means I have commented out this code so that it will not execute when I click the execute button. All right, these are all sidebars. But all right, so this is my pivot table. And then, as mentioned earlier, we have to alias this as well. So I'm going to alias it as P. It doesn't like something. It doesn't like that I missed a comma. For category in children bikes, what am I missing here? For category in children bicycles, some price. and pivot this sum total price. The moment I see some sales, total sale price, what am I missing here? Why doesn't it like
Is
my
it total sales price?
Exactly right. There you go. And how did I find that something is wrong? Because look at this red line, right? It's telling me it doesn't like something, and it's telling me invalid column name. I just have to figure out or type the right column name, and then that red line, angry red line, goes away. Okay. What else? As P. Okay. Do we have everything? Have we accounted for everything? As P. I'm probably missing a pivot, and then there you go. This pivot I started here. This is the bracket close for this, and then for category in, I'm just checking my syntax there. There you have it. And now when I run this query, look at that. Now this gives me a much better picture, right? If I did not have, say, model year in my derived table, if I don't have it, I'm going to take it out for just 1 minute. Look at that. So this gives me the picture irrespective of when I started my store in 2018 till the year 2020. This gives me the total prices. So this is one way to look at it, that where do I make what kind of bikes get me the most revenue, irrespective of what year. If I want to see the breakdown by year, I add the model year to the mix, and there you go. Now this will, so see how you can manipulate your view of data by adding columns to the derived table, like the data set that you're trying to pivot, and then pivoting it. Again, I'll go through the steps one more time. You are selecting all your pivoted columns. If I wanted, I could have done these columns only in the select list. If I only did these columns in the select list, let's see what the answer looks like. Because these are my pivoted columns, remember? It will only show me the answers to the columns that I selected in the pivoted columns list. So going back to my syntax here, it says select, and then you have to give the first pivoted column, second pivoted column, and so on. In that, I chose everything, all the pivoted columns that in that we just chose select star, and that's why it returns all the pivoted columns. That means all of these. But if you want, you can just pick and choose 2 or 3 or however many columns you want out of all the pivoted columns. All right, that from you have a data set, which is your derived table, which is the data set that you decide, okay, this is my data set, this is what I want to pivot. That goes here in the from, and then you alias it with anything. It could be alias as table 1 or anything. In this case, I just have aliased it as A. Then you use the keyword pivot followed by your aggregation function. What do you want to see? What function do you want to see? The sum of sales or the count of orders or average price or what have you? You use your aggregation function here, and then you specify what is going to be your list of columns that you want to spread out. So my list of columns is nothing but the categories from this derived table. And then I want to see these as my columns. So I take all the distinct or unique values in category, and then I make columns out of them. And then I alias it as, you can alias it as anything. Again, I chose the letter P for simplicity. And that gives you this data set pivoted, just like that. Everybody with me? Yes?
Yes, I'm
Yes.
following you.
All right, great, awesome. Let's look at one more example. And that was the one that I was trying to talk about in this. Let's try another query. Question is, write a query that returns the number of distributions of orders according to the days of the week. So say I have a store and I'm trying to cut costs. Okay, I think that I have way too many employees and I want to, reduce the number of employees that are working in my store. But I don't want to let go of employees or cut the number of employees or their hours on the busiest of days, because that would impact my business. So I want to pick a day when there is the least amount of orders or sales, and then maybe reduce the hours of employees on that day. So wouldn't this kind of output be very helpful? Because this easily helps me see that, Thursday is the day when, market is a little bit slow. And that's why maybe if I have to reduce, instead of having 3 people attending the store, maybe I can only have 2 people attending the store, and hence the cost cutting. Yes? Yes?
Yes.
All
Yes.
right. Okay, so let's look at how we can achieve it. So I want to show you another table in the same database. And that table which we are going to use is select star from, the table name is sale dot order. So let's look at everything that's there in this table first, okay? And then we will decide what we need to get this particular view of our data. So I see a lot of information. It's just information overload. I see order ID, I see customer ID, order status, the date, required date, ship date, blah. It's just way too much information. All I need to do is just tell me what day of the week is the least sale. I just want to see that pivot view that we just saw in our slide. So how do we do that? I first need to define that small data set that I'm going to pivot. Okay, so how am I going to do that? Select, obviously, from the same table. So this is my table. And what am I doing? I just want to see the order ID, because obviously I want the number of orders. So I will select the order ID that is of interest to me. And then I don't care about the customer ID, the status of their order, nothing. I just want to know when that order was placed. How do I get that information? From the order date column. And from the order date, I want to know what day of the week was on that date that the order was placed. And for that, SQL gives us some tools. So I'm going to just type it here, but we also teach all of these constructs that SQL Server offers, whether it be date, string, your arithmetic functions and whatnot. But this is a sweet shortcut that I'm going to show you. If I do day of the week, and then I tell it, give me the day of the week of order date. And I want to alias it as day of week. Okay, let's see what does this give me. All right, this is cool. So the first order ID 1 was placed on a Monday, order ID 2 was placed on a Monday as well. So this is good information, right? This is exactly what I want, except now I want to see the view where I'd see all Monday, Tuesday, Wednesday in the form of columns, and then how many orders were placed as a count of orders that were placed on that day. And for that, we are going to use pivot. Everybody with me? You like what you see so far?
Yes, I'm
Make
with
sense?
you.
Okay.
Yes, it does.
All right. So let's do it. Select star from what's my derived table? This table that I just created, this query right here, because this is what I want to pivot. So I'm just going to copy it and paste it in here. And then I'm going to alias it as my derived table. I'm going to call it as A. This is my derived table. Now what am I going to do? I am going to pivot it. So I use the keyword pivot. Yes. And now what am I trying to do? I am trying to count Monday. This is one order. This is one order. On Monday, this is, I want to count those orders. I want to count the order IDs. So my aggregate function is going to be count order ID. Yes.
Yes.
For day of the week in, what's my data set here? What are the days of the week that I'm looking for? Monday,
Tuesday, Wednesday, Thursday,
and so
Friday.
on. So I could either type it or I could just say select distinct extracted day of the week from sale order. Okay. And does it matter? The order? It doesn't. Or does it? It does, right? Because that's how we will see it in our end query. Come on. And let's do Sunday, just a little formatting here, followed by Monday. Tuesday, Wednesday. There you go, all lined up. And then, of course, we want them to be nicely comma separated. That's my list. I'm going to call this as P. And again, it doesn't like something. What does it not like here for day of the week in this? Let's see what error it gives me, what it does not like. Incorrect syntax near the keyword for days of the week in. Let's see. For day of week, did I copy this right? For day of week in, and then I open my parentheses here, and I close my parentheses here. I think it does not like the keyword as, or maybe not. And then I did count order ID for count of order ID for day of week in, and then I wonder where am I making a mistake here? Let's see. Select. Again, it doesn't like something. Count order ID for. Can anybody spot anything that is completely I'm missing out? And this is the right syntax.
I would not know. I don't know. Parentheses, I don't know.
So this, we opened one parentheses here and we closed it. This looks good. Let's see. And I have 5 more minutes to figure this out. And believe me, I will. For day of week in. Okay. Let's see if I can. Okay. I think I found the mistake. This parentheses doesn't go here. This actually, you have to specify for day of week should be this column set that I'm defining as P. Oops. That was a silly mistake on my part. But as you can see, SQL Server will tell you exactly where the mistake is. It kept on telling me that you are missing something, incorrect syntax near the letter P. So do you see where I was going wrong? I was taking this is my set of columns. So my set of columns need to be in brackets. And what I was doing is I was taking this and putting it after the P, which does not make sense. All right. And we can try and fit it in. Yeah. So this is my data set, and we can look at this previous one. You put the category, you list all your columns, and then you close the parentheses right here. You close the top parentheses, and this entire pivot is, you then call it, you give it an alias, which is also in our syntax if you look at it. So you give it for your list of columns in, and then you specify your list of columns, you close the parentheses, and then you close the parentheses for the pivot, and then you say the alias. All right. And that gives us our result, which is what we expected is the list of, sorry, not this one, but this one. All right, there it is. All right, so now I can see on Sunday, I made 226, on Monday, 233, on Wednesday, and so on and so forth. So now I see that on each day of the week, how many sales do I make? Everybody with me?
Yes.
Yeah.
All right. So that brings us to the end of this session. I hope you enjoyed this past 1 hour. I hope you learned something new, or at least were intrigued by the concept. And I hope to see you in the longer session sometime soon. Good luck, and thank you once again.